Hello there and welcome to this video on programming paradigms. In this video specifically, we're going to cover one paradigm, and that is the object-oriented programming languages. Now, why do we look at using object-oriented or OO? Well, because modern day projects and modern day scenarios, they match very well with object-oriented methodologies. And most modern programming projects use the object-oriented paradigm, and once you understand the basics of your procedural languages, then normally the natural progression is to move on to the object-oriented programming languages. And in my opinion, it's much better. We get a lot more functionality and flexibility out of these kind of languages. Object-oriented is also known as OO or OOP, sometimes referred to as OOP. And it has gained popularity amongst the programming community, and this is down to the flexibility of different languages, some being semi-object oriented so you can mix and match different paradigms. It just makes for better programming, and we can be flexible about which languages we use. Now, what do you actually get for your money? You get plenty of object-oriented support online through forums and through project documentation, and object-oriented languages allow the programs to be well structured in their nature. And it offers as well the potential for reusable code, and this is probably the greatest advantage to using object-oriented languages, especially when we get stuck into talking about classes. Now, in addition to this, you still get all of the great functionality of your other programming languages as well, such as selection, iteration, assignment of variables, identifiers, and constants. And moving from procedural to object-oriented is much more straightforward. And the key differences are that in object-oriented, what procedures were, we now replace for classes, objects, and methods. And classes and procedures, they both offer modularity, but classes allow the developer to produce more reusable code and relate their design more closely to reality. So there's no functions and procedures in this, we have methods instead. Now, the characteristics that define the object-oriented language are as follows. We have encapsulation, which is private and public. So think about encapsulation like the method of hiding things away from developers and users. We have polymorphism. So polymorphism means many forms. So it's a method of overriding behaviors based on our inputs to get a certain output. We have something else called inheritance as well, and that is very similar to the inheritance that humans have between their genetics or through the wealth. For example, if somebody dies, you inherit things. And we also have classes and objects as well. So classes and objects are all about reusable code. And then we have abstraction. Abstraction is removing complexity from whatever we're doing to allow the user just to simply do things. Now, first, let's focus on classes, objects, and methods then. So an object is a combination of data and the actions that can operate on that data. So think about a class as a definition of an object, a template or a blueprint, if you will, and it embodies all the information needed to create and manipulate objects of a particular type. So in this diagram, towards the bottom of this slide, you can see that the car is above everything else and it's slightly larger, and that's to denote that the car is what we call a base class or a superclass. And all of the cars below it, Ford, Jaguar and Aston Martin, they are all of type car. They are just objects of the car class. So a car might have things like wheels and doors and a bonnet and windscreens and an engine, etc. A Ford, a Jaguar and an Aston Martin all have those things in common. They all have the same characteristics. So instead of me defining a Ford has doors, wheels, an engine, wing mirrors, etc., a Jaguar also has an engine, wheels, doors, etc., and an Aston Martin. I'd be there forever if I was defining every single car individually every time. So what we do is we use a superclass or a base class such as car. We list the default properties of a car, and then when I create a new object, we pass on all of those default properties onto the objects. Now think about a class more closely. It has two main sections. The first being a description, also known as the attributes. If I was doing procedural programming here, the attributes are basically your variables. And in addition to that, we also have actions. And these are classed as methods. So again, if you were doing procedural, these would be your procedures and your functions. Now, methods are fundamental in object-oriented languages because a method is a piece of code that implements one of the behaviors of a class. For example, the car class would have the method turn left. So consider the picture to your right there. We have a Tesla with its self-driving capabilities. Now, every Tesla has the method turn left, turn right, slow down, speed up, etc. for its autonomous vehicles. So instead of me defining that for every model of Tesla, I would just copy or inherit the behaviors of the class. And I would inherit the methods into each class that I create. And in order to identify an individual car, it must be described. And in object-oriented programming, this means creating an object. And when we create an object in object-oriented programming, we refer to that as instantiation. And the way I remember instantiation is thinking about a class is born from a parent class. And it applies the same to you. You were born from your parents, so you were instantiated from your parents. Now, to set an attribute of a class, you need to use the reference created during instantiation. And attributes are treated as variables within the object and are accessed by using a full stop between the object name and the variable. So consider this piece of pseudocode. The first line tells us that the Ford variable or the Ford attribute is assigned or given the value of a new car. And if you're not used to object-oriented programming languages, normally we denote a class by using a capital. So I know that looks like a class to me, and also it has the rounded brackets after it, which also tells me it's a class. So when we do this instantiation on this line here, the Ford will inherit all of the attributes and all of the methods of the car parent class. And once we've done that, I use the full stop to access all of the methods and attributes inside the car class. So I can access the attribute reg number, I can access make, I can access model, and then I can print them out. I can also do anything else I can normally do with a variable, like a variable assignment. So I've assigned this string here, YR99, I've assigned Ford, and I've assigned Fiesta. And I can print them out. So the attributes are treated the same as variables. Now, something to think about is that you can assign attributes or use them in any other expressions in the exact same way you would use any other variable. However, each object that you create from the parent or base class is distinct from each other. So think of them as separate entities, even though they share the same attributes and methods. So let's look more closely then at the main areas of object-oriented programming. And the first one is encapsulation. Now, before we said encapsulation is the technical implementation of hiding within an object. So we hide things from the developers, from the users, so that they can't do anything that they shouldn't be doing. And you've actually been a victim of encapsulation before, because you have definitely inherited different things from different classes, different methods, and you've imported things and you don't know how they work. You just import them and you use them from different classes that are stored in your project libraries. So encapsulation is the hiding of the implementation of a class and controlling access to its methods and attributes. So normally in OO, you will see public and private being used to denote whether you can access something or you cannot access it. Classes can hide how they work from developers who may wish to use them in their programs, and anyone using the class needs only to understand the interface to the class. So that's its methods and attributes. As long as you know what they're called, you can call them from the class if they are public. So consider the example. I have a car. It can accelerate, change gear, and brake. They're its methods. But it also has some attributes in there as well: brand, speed, gear, color. Now, I don't want them to access the things inside the red box, but I do want them to access the things inside the green box. So I want them to accelerate. So if they use the method accelerate, that will change the attribute of speed. Now, I don't want them to change the attribute directly. I want them to use a method to control it. Same with the gear. Braking as well, I do want them to brake in the car because it would be dangerous if I didn't include that. So what we can do is we can control exactly how the user or another developer would actually use my class. So think about encapsulation another way. Here I've got some pseudocode on the left-hand side for a stack class. So if you remember, a stack is a data structure where you can push data onto the stack and you can pop data off the stack. My stack class diagram looks like this. I have 3 attributes or variables, and I have 2 methods. I have a push method and a pop method. Push takes in a parameter of data, pops the node. Now, the node itself, connected to pop here, includes the data and the pointer to the next node. Now, why am I telling you this? Well, because it uses encapsulation to access the methods of the stack class. So here on this line, we have instantiation again, just like we saw before with the car. We have an attribute called test. We assign it a new stack. Capital S again, stack. So we instantiate a new stack. Then, once we've done that line, we can then access, using a full stop, we can access the push method and also the pop method. Without this instantiation line, we would not have any reference to do these things. We are saying that test is of type stack. And that means we can access all of this code when we inherit it all. And speaking of inheritance usually this is where students get very good marks because it matches the modern day world. In the real world, inheritance has a specific meaning. We inherit genes from our parents and in some cases, money from relatives. So the idea that something is being passed down through some form of relationship, that is inheritance. And in object-oriented programming, it follows the same principle. So consider the example. If I have a car and I have a van, what's different between those two? Well, you might have differences in the size and things like that, but they have the same methods. We allow them to accelerate, we allow them to brake, we allow them to have a current gear or change the current gear using the gear up and the gear down methods. Now, in order for me to make this efficient, why am I creating things over and over again when they are identical? Well, that would be a very bad idea to do it this way. So we include inheritance by creating road vehicles. And this is a superclass, base class, parent class, whatever you want to call it. It holds the default values of these two. So what we've done is we've taken the code out of here and we've basically put them in here. So instead of me writing it twice, I've only written it once now. Then when I instantiate car and I instantiate van, it becomes of type road vehicle and van becomes of type road vehicle. It inherits all of these attributes and methods. And they might look blank to you, and so does van, it looks blank also, but they will all contain these methods and attributes. And the good thing about this is I can customize what a car is or what a car does. So if a car does something specifically different than a van, then I can list it inside the specific class. Same with van, I can list a specific method if I wanted to, or a specific attribute for that van. And that is inheritance. The next one to look at is polymorphism. And this one sounds quite scary, but poly just means many and morph means form. So we've got many forms or many outputs. So you've actually done this before. Consider the example, A plus B. If I told you that these two are integers and A has the value of 10 and B has the value of 10, if you added them up, you would output 20. Well, that's fine. If these two are integers, then the system will look at this symbol and say, this plus symbol is to arithmetically add these two numbers together. However, if I said A and B were strings, and I had cat and I had dog, it wouldn't add them together because they're strings, it would concatenate them. So the behavior has changed, although it looks identical. And that is because we are overriding the behavior based on the type of data we have and based on what your system wants to do with that. So although they look the same, they have two different behaviors. And that's what polymorphism is all about. It's overriding the behaviors you want for the task you are doing. And that means our programs can be flexible. We can enter dog into our code and it will produce woof, cat will produce a meow, and cow will produce a moo. And that is all based on polymorphism because the system in the middle can change depending on what its input is to produce a specific output. So you might think your system will behave like this, but then with a given input of cow, it'll behave like this. And then we consider our last example then, abstraction. Now I can drive a car. I have my license, I use my car every day to get to college. But if you said to me, how do you get to college in that car? I would say to you, well, I put the key in, I turn it, the engine strikes up, I put it into gear, I release the clutch, press the accelerator, and off I go. And then if I want to stop, I press the brake. I also need to not forget that I'm taking the handbrake off. So that is a very rudimentary understanding of how I get to work. If you look at it closely, there's lots of things going on underneath my bonnet. I have an engine, it's doing something, shafts are moving, we've got injectors, we've got spark plugs, we've got fuel mixtures, we've got air, oil filter, crankshafts, you name it, things are happening. Now I couldn't explain how that works, and that's what abstraction's all about. It's removing the complexity from the user to allow them to just simply use and operate whatever they need without understanding the difficulty and complexity. And I guarantee you've done this before. If you've programmed and used message boxes, or you've printed to the console, or anything else, and used any libraries or anything like that to produce something, you don't know how it does it. All you know is that if I call that and I pass it that data, it will do this. And that's all you need to know. Because if you spent your time understanding what's going on in the back and doing it yourself, you would waste an awful lot of time. So abstraction is a fantastic way of being able to speed up what you're doing and get more done because you're not worrying about the complexity of every little thing. Abstraction is just hiding stuff away from the user. And with that, quick summary. Programming paradigms, object-oriented is only one of them. We have others like procedural and visual and markup, etc. But the languages for object-oriented programming are things like Java, JavaScript, C++, Visual Basic.NET, Ruby, Scala, PHP, even Python to an extent does object-oriented or has object-oriented features, although you don't actually have to create classes in Python. So it's kind of a semi-object-oriented language. But there's four main areas to object-oriented programming, and they are encapsulation, inheritance, polymorphism, and abstraction. So thank you very much for watching, and I'm sure I'll see you again very soon.